it says in a right angle triangle ABC, altitude AB is 5 centimeter and the base BC is 12 centimeters. So, it is something like this. This is 12, this is 5. P and Q are 2 points on BC here, such that the areas of triangle ABP, suppose P is here, ABP, ABQ, and ABC, so ABC are in arithmetic progressions. So, they are in AP, he says. What do we mean by AP? The difference should be constant. Now, please note, what is area of ABP? ABP will be nothing but half into base into height, which is 5. What is ABQ? It will be half into BQ into 5, same height. And what about ABC? Half into BC into 5. Now, please note, this half into 5 is common everywhere. We can remove that. So, can I say if these 3 areas are in AP, then the distances BP, BQ and BC, BP, BQ and BC should also be in AP. If the areas are in AP, then these segments should also be in AP. That would mean what? If BP and BQ are in AP, that means if I take BP as some X, suppose, and PQ as some Y, suppose, BP and BQ should be in AP. So, that means X comma X plus 5 should also be in AP. Not just that, please note, even BC, so BP, BQ and BC should be in AP. So, whatever is the difference between these two, same difference should be remaining between these two also. So, difference here as we see is Y. So, here also the difference should be Y. That can only happen if you take BC as X plus 2Y. So, this QC is also going to be Y, you may note. Okay, so based on that arithmetic progression condition, this is what I get to know about the points P and Q. P and Q are such that if P is at distance of X units, Q further distance of Y units, then QC will also be Y units. If the area of triangle ABC is 1.5 times the area of ABP, okay. So, we know that area of triangle ABC is nothing but half into base. How much is the base? 12 into height, which is 30. And according to the question, this area is 1.5 times, 1.5 is 3 by 2 times. Triangle ABP is 30. So, when you solve this, area of triangle ABP, which happens to be half into, so triangle ABP will be 20, so which is half into base into height. So, this will be 20. So, when you solve this, the value of X, I will get it as 8 units. So, this is a distance of 8 units, I can say. So, if this is X, please note also X plus 2Y is 12. If X is 8, can I say the value of Y will be what? 2 units. 2Y is 4, so Y will be 2. So, this is 2 units, this is also 2 units. So, P is at a distance of 8 units from B, Q further 2 units from P, C further 2 units from Q. So, this is how we get the values. And now the question is, the length of PQ in centimeters is, PQ is how much? PQ is 2. So, as we can see, the length is only 2 centimeters. That should be the correct answer. I hope we are clear with this. You can note it down. Next, for some positive and distinct real numbers x, y and z, 1 by root y plus root z is the arithmetic mean of the other two. That would mean what? 1 by root x plus root y. Suppose this is the first term, second term and third term. If this is arithmetic mean of first and third term, that means they are in AP, right? The 3 terms in order are in AP. X plus root z. Can I say they should be in AP? If this 3 terms are in AP, then which of the following will always hold true? We have to check. So, what are the option choices? Y comma x comma z are in AP. Root x, root z, root y are in AP. X, y, z are in AP. Everything is in AP only. Yeah? Root x, root y, root z are in AP. Which will satisfy? Okay, let's try to check. Okay, if this is an AP, can I say reciprocal of that? Or let us do one thing before I take the reciprocal. Let me multiply throughout by root x plus root y plus root z. So when I multiply root x plus root y plus root z by root x plus root y. Okay, and similarly we could do it here also, root x plus root y plus root z by root y plus root z. Same thing, root x plus root y plus root z by root x plus root z. How much do we get that? So this one you divide root x plus root y by root x plus root y 1 is root z by root x plus root y. No, this is not really helpful. Okay. So these three are in AP. That would mean what? The middle term will be equal to average of the other two. That means 1 by root y plus root z will be equal to average of the other two terms would mean 1 by root x plus root y plus 1 by root x plus root z by 2, and that by 2 we can bring it on the other side and let us simplify. So this will be 2 by root y plus root z. When you take the LCM, you will get root x plus root z, root x plus root y upon, when you multiply these two terms, you will get root x into root x x, root x z plus root x y plus root y z. Let us cross multiply. So when you cross multiply, you will get 2x plus 2 root x z plus 2 root x y plus 2 root y z. So what I am simply doing is I am simply cross multiplying. Let us multiply this. So when you do this, it will be root x into root y, root x into root z. It will be root z into root y, root z into root z is z, root x into root y, same, root x into root z, root y into root y, and root y into root z. So when you look at both the sides, what do we get here? Observe 2 root xz. So we have 1 root xz here, another root xz here, will cancel out. 2 root xy, we have 1 root xy here, one more root xy here, that will also cancel out. So finally what are we left with? And one more thing, 2 root yz will also cancel out. And what are we finally left with? We are finally left with 2x equal to z plus y or y plus z kind of equation. So what would this mean? This would mean x is the average of y and z. That would mean y comma x comma z will be in AP, or we can also write it in reverse, z comma x comma y will be in AP. So these three terms or these three terms will be in AP. Let us check the option choices. Y, x, z, yes, exactly, the first option choice will be the correct answer. Okay. So after you simplify, you will know your answer directly. Moving on. The number of all natural numbers up to 1000 with non-repeating digits. So we don't want the digits to repeat, and up to thousands we can have single digit numbers, 2-digit numbers, and 3-digit numbers. So how many single digit numbers are there without repetition of digits? All of them. So since we want only natural numbers, we will write 1 to 9. So there are 9 such numbers. How many 2-digit numbers are there where the digits are not repeating? So since the digits shouldn't repeat, can I say, since I want 2-digit number, I cannot have a 0 here. So in how many ways can I fill up this first place? I can fill any digit from 1 to 9. So this can happen in 9 ways. After I filled up this place, can I say for the second place, I have only 9 digits remaining. So this can also be filled in 9 ways. So 9 into 9, this will give us 81 2-digit numbers where the digits are non-repeating. 3-digit number, again here also this cannot be 0. So this can be filled in 9 ways. Out of the 10 digits, 1 digit is gone. So I am left with only the remaining 9 digits. So this space can be filled in 9 ways. After filling 2 places, I am done with 2 of the digits. That means now I am left with only 8 digits. So thus the third place can be filled in 8 ways. So overall what will be the answer here? 9 into 9 into 8, which is 81 into 8, 648. So there are 648 3-digit numbers, 81 two-digit numbers and 9 single-digit numbers. He is asking us all of them. So, my answer will be, when you add them all, 738. So, option choice 3 should be the correct answer. Alright. 22nd one. If you read it, it says a lab experiment measures number of organisms at 8 AM every day, starting with 2 organisms on the day 1. So, on the first day, we have only 2 organisms. The number of organisms on any day is equal to 3 more than twice the number on the previous day. So, that means on day 2, it will be twice of this plus 3 more. So, it is going to be 7. On day 3, twice of this plus 3 more, it is going to be 17. Similarly, 4th day will be twice of this, 3 more, 37. And likewise, it will go on and on. 37 double is 74 plus 3, 77, and so on. Now, this way the number of organisms increase. If the number of organisms on the nth day, somewhere down the line, exceeds 1 million. So, this value here is more than 1 million, that means more than 10 power 6. The lowest possible value of n is. So, when does it happen? After how many days? So, as you can see, after 5th day, the number of organisms is only becoming 77. 6th day, if you will go, probably it will become some 150, 160. 7th day, it will be probably 300s, and so on. It is increasing slowly and steadily. Now, the question is, when does it become more than million, more than 10 power 6? So, one way to go about answering this question could be actually taking the pain of writing down the number of organisms at the end of each day till you get a value more than 10 lakhs, 1 million. That of course is a very lengthy approach, but it is a short way of getting to the answer. You need to just calculate double, add 3, double, add 3, double, add 3. So, just to let you know how can we probably do that to some extent. So, 6th day, what will it be? 6th day is 77 double 154 plus 3, 157. 7th day, double of this 314 plus 7, 317. 317 double 634 plus 3. 6th day, 7th day, 8th day. Double of this, it will be 1274 plus 7, plus 3, sorry, plus 3. This is 9th day. Double of this will be how much? 1270, 2540, 2554, 2557, I believe, and so on. See, it's not that easy if you will see. This is the 10th day. We only reached 10th day and we have only 2500. And from here, you have to go till 10 lakhs. So, it's going to be such a tedious task if you do it like this. Alternately, what one could try to do here is, they can try to identify a pattern if they can, right. If there is some pattern that we can generate, right, something that we can try to identify, look at, right, that's something that could be done probably. So, how can we do that? How can we try to generate the pattern here? Let us try to see. So, as you look at the numbers, right, on day 1 it was 2, on day 2 it was 7, day 3 it was 17, day 4 37, day 5 77, day 6 157, and so on, and so on. Can we notice a pattern here? So, probably, I am just guessing, I am just thinking out loud, probably something in terms of powers of 2. See, how can we possibly think of it? So, this is 2 power 1, right. This is probably 2 square plus 3, right. So, this could be 2 cube, 8 plus 9, 3 square, something like this. This is 37 is 2 power 4, 16 plus 21. I am writing just the remaining ones. 77 is 2 power 5, 32, and this will be 45. And 157 is 2 power 6, 64, 64, and this will be what? 93, and so on. So, it was 2 power 1 plus 0, and then you had a plus 3, then you had a plus 3 square, or rather 9, I will write it. I will simply write as 9. And then I had a 21, then a 45, and 43, and so on. Now look at these numbers, 3, 9, or rather 0, 3, 9, 21, 45, 93. Do we see a pattern there? Can we have a pattern there? So it's like 0, 3, 9, 21, 45, 93, and so on. And next I am guessing would be, 1 second, 24, 24, 48, 96, 96, 189 probably. Next will be 189. So next time will be 189. Do we see a pattern here? Can we have a pattern? That's what is the question we are trying to answer. I think I see a pattern here, but how do we put it in words? How do we put it in words or expression? Let's try to identify that. So you had a 0, you had a 3, you had a 9, so this is increasing by 6, this is increasing by 12, this is increasing by 24, see it's doubling, it's increasing by 48, it's increasing by 96. So the jump is doubling each time, right? It's doubling. So let's try to 3 plus 6 will give you 9, 9 plus 12 will give you 21, or rather if I want to get to 21 directly, and here if I will see 0 plus 3. So this forget the powers of 2, because powers of 2 is separated, 2 power 1, 2 power 2, 2 power 3, that is an easy nth term that I can find for this, right? Forget that, ignore that. Look at the rest is 0, 3, 9, 21, 45, 93, 189 and so on. Look at that. So the first term is 0. If I want to get to second term, I will do 0 plus 3. This I can think of it as 0 plus 3. If I want to get to third term, I would think of it as 0 plus 3 plus 6, 3 plus 6, I get the third term. If I want to get to the fourth term, I will think of it as 0 plus 3 plus 6, I will get till here, plus 12. Fourth term, sorry, this is fifth term. This will be nothing but till 21. So same 0, 3, 6, 12 till 21, and then I will do plus 24. So this way. So if I want to get to suppose nth term, as I said, please ignore the powers of 2 for a while, only focus on the remaining terms. I will do it on the next slide. If I focus on the nth term, how do I find the nth term here? Suppose I want the 10th term. How do I get that? Again, look at the pattern. If I want the second term, I will do 0 plus 3. If I want the second term, I will take only one multiple of 3. I will add it to 0. If I want the fourth term, what will I do? I will take 0 plus 3 plus double of 3, 6 plus double of 6. So basically, if I want the fourth term, I will have 4 terms here also, and possibly if you just simplify this, if you take out 3 common, it's nothing but 0 plus 1 plus 2 plus 3. So it's something like 3 into sigma 4 minus 1. 3 into sigma 4 minus 1 for the fourth term. If I want second term, how do I do that? You can again think of it as, if you take 3 common, so 3 into 0 plus 1 plus 2, so 3 into sigma 3 minus 1. 3 into sigma 3 minus 1. Thus can I say the nth term for these extra terms will be 3 into sigma n minus 1. What will that be? 3 into n minus 1 sigma is n minus 1 into n by 2. Okay, that is here. So thus overall, and please note, this is the nth term only for these extra terms. So what will be the overall nth term? The overall nth term will be 2 power n plus, I want a power of 2 plus something, and that something turns out to be this by 2. This is the overall nth term. And now I need to figure out in this expression, for what value of n minimum will this expression become more than 10 lakhs. So we will have to go for some calculations yet again here. So how can we possibly calculate? Suppose I randomly put some value, I will put n equal to 15. So if I put n equal to 15, what do I get? Observe, this will be 2 power 15, which is around 35,000. It's in thousands. And this, if I put 15 here, it would be a very small value. Right? It's not going to satisfy. Put n equal to 20. No, if I put n equal to 20, this will be a much high value, right? 2 power 20 itself is beyond a million. So we can't put n equal to 20. Put n equal to 19 here. So if I put n equal to 19, I'll get 2 power 19 plus 3 into 19 into 18 by 2. Now let's simplify this to some extent. So what is 2 power 19? This is 2 power 10 into 2 power 9. And 3 into 19 is 57 into 9. So 2 power 10 is 1024 into 512. 57 into 9 will be 450, 513. It's a very minuscule, small value compared to this. Right? Let's simplify this. Let's see where do we get to. Do we go beyond a million or not? Most likely this doesn't appear to be. Observe, this is in 500s, this is in thousands. Early 500s, early thousands. So 500 into 1000 will be something like 5 lakh, approximately 5-6 lakh, plus 500 will be still around 5-6 lakh. It is not going to cross 10 lakhs. So for n equal to 19, it's not going to cross, right? It's not going to cross, it's not going to cross 1 million, right? For n equal to 20, it's definitely going to cross 1 million because this itself will be 2 power 20, which is 1024 cross square, which itself is 10 power 6. But what's the question? If the number of organisms on the nth day exceeds 1 million, so it should exceed 1 million, what's the lowest possible value of n? On day 1 it is, okay, on day 2 it is, on day 3 it is, and so on. So for 19th day, we are not crossing over to that, we are not crossing 1 million, we are not exceeding 1 million. Okay, let's look at this 22nd, the last problem in today's discussion. A lab experiment measures the number of organisms at 8 AM every day, starting with 2 organisms on the first day. Number of organisms on any day is equal to 3 more than twice the number on the previous day. We'll continue with the rest of the question a little later. Let's write down what do we know. On day 1, there were only 2 organisms. Day 2, the change is as follows. Whatever is there, it will become double and 3 will be added to it. So can we write as 2 square plus 3. Day 3, which is nothing but 7 by the way. Day 3, whatever is there will be doubled and 3 more will be added to it. So when I simplify, this will be 2 into 2 square 2 cube. This will be 2 into 3 plus 3. If I take 3 common, 2 plus 1. 2 into 3 into 2 plus 1, or if I want to write it down, I could also write it down as, because it's ultimately 3, 2 square minus 1, something like this. This I can write as 2 power 1 minus 1. This I can write it as 3 into 2 power 0 minus 1, which is 1 minus 1, 0 anyways. Day 4, if you look at, whatever is there will be doubled and 3 more will be added to it. So when you simplify, what does this become? This is 2 power 4 plus 2 into 2 square minus 1. If I take 3 common, so I'll get 3 into 2 into 2 square, 2 cube, 2 into minus 1 minus 2 plus 1. So 2 cube is 8 minus 2, 6 plus 1, 7. So can we not simply write it as 2 cube minus 1 here? It is nothing but 2 cube minus 1. And day 5, if you look at, again the same thing, double of this. So 2 into 2 power 4, 2 power 5, 2 into this. So if I take 3 common, so 2 power 4 minus 2 plus 1, which is nothing but 2 power 5 plus 3 into 2 power 4 minus 1. So you notice a pattern here. The first day, the number of organisms are power of 2, day 1, 2 power 1 plus 3 into 2 power 0 minus 1. Day 2, 2 square, 3 into 2 power 1 minus 1. Day 3, 2 cube, day 3 it's 2 cube plus 3 into 2 square minus 1 and so on. So can I generalize and say on day n, number of organisms should be 2 power n plus 3 into 2 power n minus 1 minus 1. So when you simplify this, what do you get? 2 power n plus 3 into 2 power n minus 1 minus 3. This is what is the expression, general expression for the nth day number of organisms. According to the question, if the number of organisms on the nth day exceeds 1 million, so this should be more than 10 lakhs. This should be more than 10 lakhs. Then the lowest possible value of n is how much? So when I take that inequality, if I take this minus 3 on the other side, can I write 2 into 2 power n can be written as 2 into 2 power n minus 1 plus 3 into 2 power n minus 1 will be greater than 10 lakh and 3, something like this, 10 lakh 3. So this is 5 into 2 power n minus 1 is greater than 10 lakh and 3, divide by 5 on both sides. So 2 power n minus 1 should be greater than, when you divide this by 5, so 10 lakh by 5 will be around 2 lakh, and in fact 2 lakh and 0.6, 3 by 5 is 0.6. So some power of 2 should exceed 2 lakh. So what power of 2 will exceed 2 lakh? Let's try to check. So I know 2 power 10 is 1024. 2 power 5 is 32. So even if I multiply these two, that is if I take 2 power 15, I will still get something around 33,000. I will not get 2 lakh. Let's go further. If I multiply this with 2, so I will get around 65,000, 32, 33 double. 2 power 17 if I do, double of this, I will get still 130, 135,000. 2 power 18, for the first time I will go beyond 2 lakh. So thus by this table can I say the minimum value of n, or rather minimum value of n minus 1, n minus 1. Should be 18, because at 18 it's going beyond 2 lakh, and hence can I say the minimum value of n will be 19. So that means he's saying on the nth day the number of organisms exceeds 1 million, the lowest possible value of n is, will be 19. So 19 is going to be our correct answer for this question. So with this we have come to the end of the session. I hope we have followed the questions. We will come out with more such videos wherein we will be discussing other year CAT papers also, other slots also. Right? So before your final attempt for the CAT, so these would serve as quick revision to all the good quality questions that were asked in the previous year CAT papers. So please do watch these videos before you go for the actual CAT, or keep watching them, alright. It says there are some really good questions. For example, the last one that we did is a really good question. So if you, for example, identifying this pattern itself is such a difficult job. So here the toughest part is this, not this of course. This is just basic calculations. Identification of the pattern was like really complex. So try to, and there are many such questions that we have solved in today's class without, for example, this one also is a really interesting question which looks difficult, but when you simplify it really becomes easy, and likewise there are others. Please do watch the video, alright, and not once, I would say more than once, at least few questions, and this would definitely help you prepare well for your CAT. On that note, let me end the session here. Thank you and all the very best.